capital F is an antiderivative of f of x, then when you take a derivative of capital F, it should turn back into f of x. And so if we want to find capital F, its derivative should be the function we're given up here. So we need a fraction. I'm going to click the square root of x using the buttons on the side. Okay, they say multiply the numerator and denominator by the conjugate of the denominator. So let me take this aside. So if we multiply by the conjugate of the denominator, you'll want to consider this in parentheses because you're multiplying the entire numerator times the entire denominator. So the quick thing with multiplying by the conjugate, 14 times 14 is 196. The middle terms always cancel out because you're going to have plus 14 square root of x minus 14 square root of x. And so negative square root of x times square root of x makes x, as we know from algebra. And then when we multiply the numerators, it's 2744 plus 196 square root of x minus 14 square root of x, and then this is going to be minus x again. 2744. We're just combining like terms up here. 196 minus 14 makes 182 square roots of x. Okay, so we've done what they've asked for. This is what they were asking us to do, is to multiply by the conjugate of the denominator. So the conjugate is just opposite sign. We need square root of x. So they wanted you to multiply the numerator and the denominator by the conjugate. And then simplify. So I didn't get this. Yeah, I got 14 plus something. Wonder how they did that. I don't know how they simplified. Did they factor? Two numbers are multiplied by 2744. No, that can't be it. I gotta pause. Sorry, one quick mistake I just caught myself doing is negative x times square root of x makes x to the 3 halves, because 1 for a power plus 1 half makes 3 halves. So I'm guessing that you can factor out 196 minus x from the numerator for them to have simplified like that. And we got 196 in the denominator. So what goes in this parentheses? So if you're gonna have a 3 halves power, then this has to be square root of x. That way x times square root of x will make 3 halves x. And so if we multiply, that's going to give us 196 times square root of x. So we need to reduce that by 14. So we'll subtract 14 here, I think. Does that work out? Let's check. So this would make negative x to the 3 halves. That would make 196. That needs to be a positive because square root of x and negative x plus 14, we need that to subtract to make 192. And then I think we got everything else. Okay, so it's a tough algebraic problem here, but you can factor the numerator to be to be what I have here. And so the 196 is cancel out, so I say it's square root of x plus 14 when you simplify. So this is 14 plus square root of x is what we want here. What do they want here? Okay, so they want to know where an f of x is not defined. So when x is less than 0, it's not defined because that'd be a negative. X is also, f of x is not defined when we have a divide by 0 problem. So when 14 minus 14 would make 0. So we need 14 squared here. If you were to plug 196 into this function, you get a divide by 0 problem. So that's where it's also not defined. Okay, so if you take an antiderivative term by term, it has capital F plus capital G. So it's similar. It's not the same, but it's similar to the distributive property. You can take an antiderivative term by term, just like with derivatives. This is just general form. If you have x to the nth, the power goes up by 1, but you need to multiply by the reciprocal. Antiderivative x to the 1/2, the power goes up to 3/2. And we need to multiply by the reciprocal power, just like we've seen in other integration problems. When you take a derivative, the constant can factor out. So they're just trying to emphasize that this is, the derivative of a constant times x to the first power is just k. The antiderivative of 14 is 14x. Okay, so all you have to do to take an antiderivative of this, the antiderivative of 14 is 14x. The antiderivative of x to the 1/2 power is the power goes up by 1. 1/2 plus 1 is 3/2. Then you always multiply by the reciprocal of that new power. Oops, that's not the reciprocal though. That is. I forgot my arbitrary constant c, just like I did in another video.